Good morning. So today our next lesson in chapter 7 is on the geometric sequences and series. First we kind of went over sequences and series in general. Then yesterday's lesson focused on arithmetic sequences and series. And today we're going to go over geometric sequences and series. So a geometric sequence is a sequence in which the ratio of any term to the previous term is constant. So essentially, if you take any number in your sequence, you divide it by your previous number, whatever answer you get stays constant no matter which two numbers you divide in the sequence. And this is called a constant ratio, which is known as the common ratio, and we're going to use the variable r for that. So kind of the way I look at the pattern to determine if it's geometric or not is, when it's arithmetic, the numbers can either be added or subtracted by a constant. So, the ones we were doing yesterday, maybe you add 2, add 2, add 2, or subtract 3, you would get the next number in the pattern. So when you look at a geometric sequence, it's basically something being multiplied or divided. And if you recognize, the number's going up by multiples of 2, or they're being divided by something, then that's how you know it's geometric. So if I'm going to look at, let's say, this first example here, how would I get from 4 to -8? Well, I'd have to multiply that by -2. To get from -8 to 16, I would multiply that by -2. To get from 16 to -32, I would obviously multiply that by -2. So we know that this is a geometric sequence. Now, if you're trying to find that common ratio or that r value, the way they describe it here is they talk about that it's the ratio of any term to the previous term. So for example, to find the r, you could take, let's say, -8 and divide it by 4, and you would get -2. Or you could take 16 and divide it by -8, and you should still get -2. So that's what the common ratio is. So in this problem, the common ratio is -2. But when you're looking at the sequence, it's really kind of like, well, what is each number getting multiplied by to get to the next number? So if we take a look at number 2, how would I, 1 times 2 is 2. 2 times 3 is 6. 6 times 4 is 24. So this time, even though the numbers are being multiplied to get to the next number in the sequence, it's not being multiplied by the same constant or common ratio. So this would not be geometric. And of course, if it's added or subtracted, then it's not either. So the nth term of a geometric sequence with the first term known as a sub 1 and a common ratio factor is given by r. This is the formula here. A sub n equals a sub 1 times r raised to the n minus 1. Now, even though I don't think the book, and certainly not these notes, they don't have a parenthesis around the r, but I think it's a lot easier to put it with a parenthesis. The reason is because when you follow the order of operations, or PEMDAS, if you're solving something like this, you would have to do the exponent first, right? So you would take whatever that r value is, you would raise it to that exponent. The problem is when the parentheses are there, for some reason, people have no problems with that. They don't make a mistake. However, sometimes when the parentheses are not there, people have a tendency to multiply the a sub 1 and the r together and then do the exponent, which would obviously be wrong because you wouldn't be following the order of operations. So I think it's just a helpful little thing to put the r in parentheses. So that's how I'm always going to do it, because I feel like it helps people avoid making mistakes with that. And it keeps it a little more organized so the numbers don't kind of smush together and stuff like that. Okay, so we're finding the common ratio for numbers 1, 2, and 3 here. Now, when you find the common ratio, you basically have two options. One, you can just kind of glance at it and see if you notice a pattern of something being multiplied by each time. So when you look at this, you might be like, oh yeah, this is going to be multiplied by -2, multiplied by -2, multiplied by -2. So we know the r value is -2. So you can just do it that way if it jumps out at you, if you recognize that pattern. whatever's being multiplied. Now, if you're not sure, sometimes the numbers are decimals or fractions or something weird that you can't just like figure it out in your head. That's when you would take any number in the sequence. So I'll start with 6. You divide it by the preceding number. So 6 divided by -3, you're making a ratio. And then you simplify it and we get -2. Now, don't just stop there. You want to check at least one more to make sure it stays consistent or constant. So if I started with -12 and I divided that by my preceding term, I would also get -2. Or if I did 24 divided by -12, I would also get -2. So we know that that common ratio is r equals -2. Okay, so for number 2, you might notice the numbers are decreasing this time. So a lot of times people say like, oh, well, it's going to be divided by, and I think this one is just 2, right? So divide by 2, divide by 2, divide by 2. Well, that's great and all, but your r is not 2. The reason is because it's what's being multiplied by each time. So if we're dividing by 2, what are we really multiplying by? Well, you're really multiplying by 1/2. So your r value is actually going to be 1/2 for this one. Now, again, if you're a little bit confused, you're not sure, wait, is it 2? Is it 1/2? You can do the ratios and see. So you'd have to start with at least the second number, divide it by the one right before it, and reduce that, you would get 1/2. You could test it for the next combination. So take 34, divide that by the number before it, and that would also reduce to 1/2. Or you could take 17 and divide that by the preceding number, and that would also reduce to 1/2. So that way we know that 1/2 is actually the r and not 2. All right, and then our third example here. This time is a little trickier because you have the fraction. So this is where sometimes it's just helpful to do it on your calculator. So if I'm going to take 3/10 and divide that by 2/5, okay, and you can certainly do this on your calculator, I'm going to change that sign to multiplication and flip that second fraction. And this is going to end up with 3/2. So I'm going to try it for another combination as well. So if I had 9/40 divided by 3/10, leave the first fraction, change to multiplication, flip the second fraction, right? Now I'm just going to simplify here, cross canceling. I get 3/4. Oh, and then the last one was also 3/4. Sorry about that, 2 times 2. And then if I'm going to look at my third one, 27/160 divided by the 9/40, as now you could probably tell I'm going to change that to multiplication and then flip it. So this is going to be a 1 and a 3. This is going to be a 1 and a 4. And again, we get 3/4. So our r here is 3/4, or you might have 0.75 if you did it on your calculator. But that's an example of where you're probably going to want to use that common ratio method to find the r value versus just trying to figure out what's being multiplied by in your head. You might be able to do it. That's great. If you can't figure out what's being multiplied by each time in your head, then you can just take any number, divide it by the preceding number, make sure that stays consistent, and that would be your r value. Now, as far as the a sub 1, if they're giving you the sequence, the a sub 1 is obviously the first number. Same thing as yesterday with the arithmetic sequences. That first number in your sequence would be your a sub 1, so nothing's changed there. So when we move down here to these examples, we're going to write a rule for the nth term, and then we're going to find a sub 7. So writing the rule, then finding a sub 7. So writing the rule for geometric is actually easier than writing the rule for arithmetic because you plug it in and you're done. Like there's literally nothing else to do. With the arithmetic, we had to plug them in and then we had to distribute to get rid of the parentheses and that sort of thing. So you really just need 2 things. All you need is your a sub 1, which is the first number in the sequence, and then you need that r value, which we just worked on finding. So here, what am I multiplying each number by to get to the next one? Now, if you're not sure of that in your head, take a number in the pattern, divide it by the preceding one, and that simplifies to 3/2. Then I'm going to try negative 12 divided by negative 8. That also simplifies to 3 over 2. So that tells me my R value is 3 over 2. So if I'm going to write my rule now, using the formula up here, right? So it's going to be A sub n equals my A sub 1, which is the negative 8, the R value, which, like I said before, I like to put it in parentheses to kind of keep it separate. And then you're going to raise that to n minus 1. So this is what your rule would look like. So after we do that, we're going to find A sub 7. So all you're going to do is put in a 7 for your n value. So obviously, using the order of operations, right, you're going to do 7 minus 1, which is 6. Then you're going to do 3 halves raised to 6 and multiplied by negative 8. And obviously, you can do this on your calculator, but the answer would be 729 over 8. And if you have a decimal version for that answer, that's fine too, as long as you understand where we get that from. Okay, so let's take a look at number 2. So again, our A sub 1 is that first number in the pattern. Then we're trying to figure out what's being multiplied each time here since it's geometric. So 1 times negative 4 is negative 4. Negative 4 times negative 4 is 16. 16 times negative 4 is negative 64. So I'm pretty sure my R value is negative 4. So if I want to check it using the common ratio method, I can take negative 4 and divide it by 1. I can take 16 divided by negative 4. Or I can take negative 64 and divide that by 16. But notice they're all giving me that common ratio of negative 4. So now to write my rule, I'm just substituting those two things into the formula. So 1 times the negative 4 goes in parentheses and it's raised to the n minus 1. Now, because the A sub 1 is a 1 here, you really don't even need to write it. You could just write negative 4 raised to n minus 1. But this is an example where the parentheses are actually necessary because you have a negative number as your R value. So again, I'm going to tell you this like as many times as I can, put the R value in parentheses always. It's never going to hurt you or be wrong to put the parentheses there, but there will be situations where it may hurt you or it may be wrong if you don't put them. So rather than having to worry about it, just always put them around that R value and you'll save yourself the trouble. Now we're going to use the formula to find A sub 7. So all we're doing is plugging in the 7 for the n, and then you're using your order of operations to work it out. So negative 4 to the 6th power, which is 4,096. And then you would multiply it by the A sub 1, but that's just a 1, so it's not going to change anything. So our A sub 7, or our 7th number in the sequence, would be 4,096. Okay, so moving on to the next page, we're now, and I'm going to write that formula up at the top just as a reference in case we need it. So it's a quick look here. Okay, so we're going to write the rules here, but this time they're giving us some different information. So number 1's pretty straightforward because they're giving us the two things we need. They're giving us the R value and the A sub 1. So in order to write the rule, you're just simply plugging in the 4 for the A sub 1, the 3 for the R, raising it to that n minus 1, and then you're basically done. Nothing else for you to do there. Okay, now number 2 and 3 are a little bit different. They're giving us the R value, but they're not giving us the A sub 1. So what happens in that situation is you're going to plug in the R that they give you. You're going to plug in the n and the A sub n with whatever term in the sequence they're giving you, and you're going to solve for the A sub 1. Once you solve for the A sub 1, you can then go back and write the rule. Now, you might remember from yesterday when we did arithmetic, if they're only giving you the third term, one option, right? If they're giving you the third term here and they're telling you it's 72, right? And you need to know, well, what's the first term? And you know the R value is 6. Well, what number times 6 is 72? And what number times 6 is 12? So you could work backwards, especially on one where they're giving you like the third term. They're giving you the R. you could do it, right? So 72 divided by 12 is 6. 12 divided by 2 is 6. So that's one way to get the a sub 1, and then you can go ahead and write your rule. But let's say like the number is much higher in the pattern. You don't want to fill out a pattern with 20 numbers, so you can't always use that option. So if you had to do it algebraically, I'm going to put my 72 in for a sub n. My r is 6, and then I'm going to do 3 minus 1. So that's going to give me 6 to the second power, which is 36. And then when I divide, I get a sub 1 equals 2. So notice I got the same answer either way. So now when I go to write my rule is just a sub n equals 2 times 6 raised to n minus 1. Again, whenever you write the rule, the n still needs to be a variable, and the a sub n is the variable. The a sub 1 and the r are the ones that get plugged in because those are constant. The first number in the sequence can't change, and the common ratio doesn't change, but the other numbers in the sequence depends on which one you're finding. Okay, so now we're going to do number 3. This time they're giving us the fourth term in the sequence. And they're telling us it's 128, and we obviously need to find the first term in the sequence. Now you can work backwards for this one because they're only giving you the fourth term, so it's not too bad to work backwards, knowing the multiple is 4. So 128 divided by 4 is going to be 32. 32 divided by 4 is 8, and 8 divided by 4 is 2. So again, we have that a sub 1 is 2. If we have to do it algebraically and use this formula up at the top, I'm going to put in 128 for my a sub n, and then my 4 is my r, and then I'm going to do 4 minus 1 because 4 is my n. So that gives me 4 to the third power, which is 64, divide, and again, we get a sub 1 equals 2. Okay, so when they're giving you a number that's not too far in the pattern, you could figure it out either way. When they're giving you something pretty far in, if they're giving you a sub 32 or something like that, then you'd probably have to do it algebraically. So once you get that, you want to just plug into your rule. So a sub n equals 2 times 4 raised to the n minus 1. And now you can use that rule to find any number in the sequence simply by plugging in the n value. Okay, so now going on to geometric series. So again, series is the sum of all the numbers in the sequence. This formula is a little bit more complicated, particularly when you're going to use your calculator. So I'm going to have to show you on my handheld here because my computer version is still not back in action. But basically, you need 3 things. You need your a sub 1, you need your r, which you'll use in 2 different spots, and you'll need whatever n value is. So the a sub 1 is the first number of the sequence, just like we were doing. The r is that constant, the common ratio or that constant term you get. And then the n can be variable. It depends on like how many terms you're adding up. So if you want the first 10 terms in the sequence, your n is 10. If you want the first 5 terms, it's 5. If you want the first 20, it's 20, whatever it happens to be. So that has to be given to you. So using this formula, find the sum of the first n terms of the geometric series. So we have our n value that's given to us. The a sub 1 is basically given to us because they're listing the sequence here. And now we need to find that r value, that number that's being multiplied by each time. Now, 1, 5, 25, 125 is a pretty easy pattern to figure out that you can tell each number is multiplied by 5 to get the next number in the sequence or series in this case. So r is 5. Now, when you go to plug this stuff in, this is where people make mistakes. It's simply by how they're working it out on their calculator. So first thing I would do is fill in the numbers, right? So a sub 1 is 1 on the outside. Then inside the parentheses, you're going to have 1 minus 5 to the 10th power. And then you're going to have on the bottom 1 minus 5. Okay, so now when you're working this out, the easiest way to do this on the calculator is not to enter it all at once. So what I normally do is just do this part here on your calculator because you can do it pretty easily. So on the calculator, you're going to just write 1 minus 5 raised to the 10th power. So if you can see this right here, you're just going to type it in like that, 1 minus 5 raised to the 10th power. And when you hit equals, you should get this, where's my camera there? Negative 9765624. Okay, now you don't have to write this down on your paper because you're going to leave it in your calculator screen. I'm just writing it down so you can follow along. Now on the bottom, 1 minus 5, you probably can do that in your head and get the negative 4. So I would just leave this number on your calculator, right? Divide it by negative 4. And then now you have 2441406. Okay, again, you didn't have to write anything down, it's still in your calculator. Then all you're going to do is you would leave the number that's on your screen, which right now you would have 2441406 on your calculator screen, and you would just multiply it by that number out front, which in this case is a 1, so it's not going to change anything. So you won't even have to do that step. But if it was like a 4 or a 2 or any other number, obviously you would have to do that. So that's why I just demonstrated it. But that's your answer. So really, you're just putting in that numerator I highlighted in yellow. Then you're going to divide that by this number here on the bottom, which you should be able to get from doing that in your head. And then whatever's on your screen, you multiply to the number out front. That's going to be a lot easier than putting all of this in with a whole bunch of parentheses. Okay, so let's try the next one. So again, we have the n value. We want to know the sum of the first 9 terms of the sequence. And we know the first term in the sequence is 4. And then the r value is what is being multiplied by each time. Well, we probably can see that we're dividing by 2 each time, which means we're really multiplying by 1/2. You can take any number in that sequence or series and divide it by the previous one, you would get 1/2. So now when we plug into this summation formula, our number on the outside this time is a 4, and inside we have 1 minus the r value raised to 9, and then on the bottom 1 minus 1/2 again. Okay, so this one's not too bad. I mean, we do have fraction there, but that's not the end of the world. So again, the first thing you want to do is that numerator, and you want to do this part on the calculator by itself. So I would just do 1 minus parenthesis 1 divided by 2, close the parenthesis, and raise it to 9. So this is how it's going to look on my calculator. 1 minus 1 divided by 2 in the parentheses raised to 9. I hit equals, and I get this really crazy decimal, right? 0.998, blah, 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 right? So again, you don't need to write it down. You want to leave that in your screen because you're just going to divide what's on your screen now by this 1 minus 1/2. Well, what is 1 minus 1/2? It's just 1/2. So I'm going to leave this on my screen, and I'm just going to divide it by parenthesis 1 divided by 2. I can do it that way. Or you could divide it by 0.5, like 0.5. If it's a fraction like 1/2 where it has like an exact decimal like 0.5, you can do that. If it's something like 1/3 though, you would have to do it as a fraction. So now I have this number here, this 1.9960 whatever. So leave that on your screen and just multiply it by 4. And then that would be your answer, 7.98. So now at this point, this is when you would round your answer. So 7.98. So your final answer, you can round it 2 places if you need to. This was 7.98. Do not round prior to the final answer because you may end up being too far off. And with all the assessments being multiple choice right now, I wouldn't want that to throw you off. Plus, it's easier to just do it on the calculator the way I was kind of just showing you. Okay. So moving on now, the last thing we're going to review is how to do this when it's written in summation notation versus the sequence or series notation. So this time it says find the sum of the series. We're doing the exact same thing. The only difference is we're getting the information from the summation notation. Now again, as a little reminder, just to put this in front of us, the rule formula is a sub 1 times r raised to n minus 1. And the summation formula is the a sub 1 over 1 minus r to the n over 1 minus r, right? So this is important because this basically tells us what a sub 1 and r are. So if you look here, this 6 is your a sub 1 and this 2 is your r. So we already know a sub 1 is 6. We know r is 2, and those can be just pulled right out of that little rule written on the side there, or the right-hand side of the sigma. And then depending on how many steps you're doing, so if you're going from 1 to 10, then you know your n is 10. Okay, so that's how you would do that. So now, to do your summation, same formula, the a sub 1 goes on the outside, 1 minus the r raised to the n value over 1 minus the r. And then you're just going to put that into your calculator. And you should end up with 6,138. Okay, so again, you want to do the 1 minus 2 to the 10th power. Get that answer on your screen, divide it by -1 because 1 minus 2 is -1. Get that answer on your screen and then multiply that out to the 6. Okay, so then the next one here, we know that the 5 is the a sub 1, the r is the 4, and we're going from 1 to 8, so n is 8. So a sub 1 is 5, r is 4, and n is 8. And then we would just plug them in accordingly. So we have the 5 on the outside, 1 minus 4 to the 8th power over 1 minus 4. And when you work that out on your calculator, I believe you get 109,225 for the sum. All right, so now there's no problems in the notes like this, but I'm just going to show it to you in case it pops up on one of the homework problems or something like that. But let's say you had like the problem we had in number 1, okay? But it went from, let's say, 3 to 10. That was the difference, instead of going from 1 to 10. So what you would have to do in that situation is you would have to find the sum for n value of 10, and then you would subtract the sum for the n value of 3, basically. So you'd have to find 2 summations and then subtract them, because when you find the summation with the n value of 10, it's adding up all the numbers in the series, 1 through 10, the first 10 numbers. But we don't want to include the first 3, or I guess in this case, actually, I'm trying to think, you'd probably have to do 2 if you want 3. Yeah, so it's the first 2 that you don't want, actually, which is a little bit confusing. So the first 2 we don't want, so we're going to subtract them out. And you would do it like that. Yeah, and that's it. I don't think I gave you any of those on the quiz or anything like that, but just in case you happen to pop up on one of those on the homework or something like that, that's what you would have to do for that, so if you're confused. All right, and that's it for geometrics. So I'm going to give you guys the homework practice on the geometric sequence and series for today, and then tomorrow we'll be reviewing, and then we will have our quiz on Monday. Have a great rest of your day, guys.